Alright, sometimes when you're solving linear inequalities, um, there won't actually be a solution. So it's kind of a, I don't know, um, it's kind of a bummer, I guess, but sometimes it's kind of funny. So, when there's no solution, there's no possible answer, um, there's nothing that'll satisfy the linear inequality, then the solution, quote unquote, uh, is called the empty set, which is the set of all numbers where there are no numbers. I mean, it's a set that's empty. So we have a set of numbers and there's nothing there. And just a symbol to kind of express this in a shorter way is this kind of zero type thing. So, if you're asked what's the set of all numbers for which, 2x plus 10 is less than 2x, um, and you need to say something other than, like the full sentence, there is no solution, you can say, your answer could be the empty set, meaning there is no solution, right? Just a fancy way of saying there is no solution. Um, yes. So let's look at some examples. Um, and here's my basic idea is look for nonsense. When you see nonsense, the answer is that there is no answer, or the solution is the empty set. There is no solution. Um, so here's some examples of the kind of nonsense you can see when you're trying to solve a linear inequality with no solution. You could have something like, and this is sort of like logical nonsense. The absolute value of x is less than zero. Well, can the absolute value of anything be a negative number? No. I mean, the absolute value of 3 is 3. The absolute value of whatever is some kind of positive number, or at the most 0, right? Absolute value of 0 is 0. Uh, the absolute value of something cannot be less than 0. So this just doesn't make sense. So this you know this inequality, or an inequality that you could reduce down to this, would, there's no solution. This just doesn't make sense. Another kind of nonsense you could come across is if you mess around with the equation long enough and get it down to something like this: 100 is less than 3. I mean, no, it's not. It's way bigger than 3. This. So if you were to work with a linear inequality and get it down to something that just is total nonsense like this, then the answer would be the empty set. There's no answer. There's no solution to the inequality. And then another kind of nonsense you'll come across is something like, and this is more for compound inequalities, where your conditions are that x has to be less than 2 and greater than 9. Well, there's no number that's less than 2 and also greater than 9 at the same time. So, it's like being between a rock and a hard place, as they say. There's just, you can't do that. So if you get it down to nonsense and you haven't made any mistakes on the way towards that nonsense, then you can confidently say the answer is the empty set, the set in which there are no numbers because there are no solutions. Um, right. So let's look at some examples, some concrete examples. Um, 2x plus 10 is less than 2x. Well, let's just translate this to English. I mean, we don't even have to try to solve this. We just translate it into English and ask ourselves, what is this? What is this saying? What does it mean? This is saying 2 times a number plus 10 is less than 2 times that number. I mean, what? Uh, so, you know, that's not gonna work. But just to prove it to you, I'll show you. So we want to get x's on, just one side of the equation. So maybe I want to move this 2x over to this side, or the inequality, excuse me, not the equation. Let's say I move this 2x over by subtracting it. So I subtract by 2x, so I've got to do that to the other side of the inequality. So left over here is 10. 2x minus 2x is 0. So I've got 10 is less than 0, which is just not true. So this would be, this is nonsense. Nonsense. So the answer for this inequality is the empty set. Um, or you can just write out there is no solution. That's fine. But if you don't feel like writing all that out, you just write this symbol that means the empty set. All right, so let's look at another example. We could distribute that 5, so 5 times x is 5x. Distribute, 5 times 2 is 10, so this would expand to 5x plus 10 is less than 5x minus 3. I think you can see what's about to happen. Let's say I move this 5x over. I subtract both sides of the equation by 5x, so um, this is gone, and this is gone. So we've got so 5x minus 5x is 0. 5x minus 5x is 0. So we've got negative 3 is greater than 10, which that is not true. So there is no solution to this inequality. Um, Now, yes. So what about this one? 7x minus 10 plus 3x is less than or equal to 2 times 5x minus 100 billion. Um, let's see. So I don't know. Just start doing stuff to it. So 2 times 5x is 10x. 7x plus 3x is 10x. I'm just combining like terms. So we got 10x minus 10 is greater than or less than or equal to 10x minus all this stuff. Well, if you notice from these other two examples, we've got 10x on this side of the equation and 10x on this side of the equation. So you know that these things will cancel out. We've got minus 10 um, is less than or equal to minus 100 billion. That's not true. So no solution. So if it's not immediately obvious uh, that there is no solution, just follow the rules of algebra to kind of work with the inequality, and then when you get to something that's obviously nonsense, then you can say there's no solution. And if you don't get to something that's obviously nonsense, then you've solved the inequality. So look out for this kind of thing. And if you get something that's telling you nonsense, don't panic. It's not your fault. It's not that you did something wrong. It's just that there's no solution to the inequality. So then you say there's no solution.